Welcome to the debate. It is January 2026, and the landscape under our feet has shifted so dramatically that if you blinked, you probably missed the revolution. We are stepping into a world where the way we interact with artificial intelligence has fundamentally changed.
Changed is putting it mildly. We are long past the days of typing, please rewrite this email into a chat box and just, crossing our fingers. That feels like ancient history now. The discipline of interacting with these models has matured, it's hardened, and honestly, it has split right down the middle.
And that's exactly the friction we need to explore today, because the central question staring us in the face is this: does the human element still matter? I look at where we are now, and I see prompt engineering as a high-stakes art form. It's a nuanced skill of human-AI communication, of linguistic finessing, of creative direction.
See, I think that's just romanticizing an inefficiency. It's the difference between whispering to a ghost and wiring a circuit board. And I think the industry is finally waking up to the fact that whispering is not a strategy.
Whispering might be the wrong word. I'm talking about orchestration.
Call it what you want, but I'm here to argue that manual prompt fiddling, staring at a cursor and changing please to kindly to see if the output gets better, is dead. Or at least it should be. The reality of 2026 is automated optimization. We are talking about DSPy compilers, strict security architectures, and treating prompts like programmable interfaces, not chat logs.
If you're still handcrafting prompts, you're essentially coding in assembly while the rest of us are using Python. I see why you think that. And it's a seductive argument. Efficiency usually is. But let me give you a different perspective. I represent the view that prompt engineering is, at its core, the sophisticated skill of crafting context. It involves employing advanced reasoning structures. We're going to talk about things like the tree of thoughts and reflection, and orchestrating a multimodal conversation to unlock capabilities that raw code simply cannot access.
And I come at it from a different way. I'm saying that manual approach is inefficient and frankly dangerous. The future is about optimization algorithms that find the best prompt for you and security scaffolds that prevent that conversation from being hijacked.
Then let's get into the weeds. I want to start by addressing the elephant in the room: performance. There's this misconception, especially among people who just use these tools casually, that large language models, these LLMs, just work right out of the box. But the data shows that high-level performance is not automatic. It depends entirely on how we guide them.
Go on.
Look at the evolution we've seen leading up to 2026. We moved from simple instructions to complex cognitive architectures. Back when Google's Palm model was being benchmarked, there was a landmark study showing that applying chain-of-thought prompting, literally just asking the model to reason step by step, improved math accuracy from a dismal 17.9% to 58.1%.
Right, that was the let's think step-by-step revolution.
Exactly. It wasn't a code change. It was a prompt change. It was a human insight. That's not a marginal gain. That's a transformation. And it didn't stop there. Consider few-shot prompting. A label box experiment demonstrated that on classification tasks, zero-shot prompting, so just asking the question cold, achieved only 19% accuracy. But adding just a few examples, the few-shot technique skyrocketed that accuracy to 97%.
Sure, the numbers are impressive.
My point is that the human ability to identify which examples to show and asking the model to break down complex logic is what makes the AI a dependable partner. You can't automate the intuition of understanding the nuance of a specific legal brief or creative writing task.
I'm sorry, but I just don't buy that. Let me tell you why. You're citing valid improvements. Chain of thought, view shot, but you're attributing them to the wrong mechanism. You're saying a human must handwrite these chains of thought or handpick these examples. The reality in 2026 is that manual prompt engineering is giving way to prompt compilation.
Compilation? You're treating English like it's C++ code.
Because it is functioning that way. Look at the perspective from StatSig. They point out that manual prompt fiddling eats hours of developer time and often misses the mark. You sit there tweaking words, hoping for a better result. The solution isn't guesswork, it's programmatic search. We're seeing the rise of DSPy compilers. These tools automate the creation of those few-shot examples you love so much. They handle instruction tuning, not by feeling, but by math.
But can a compiler understand the intent of the task?
It doesn't need to understand intent in a philosophical sense. It needs to understand metrics. Reliability comes from signatures, defining your inputs and outputs rigorously, and then optimizing against a metric. If I want the model to summarize news, I define the input, which is text, and the output, a summary. The compiler then figures out the best prompt to get from A to B.
That works for rote tasks, but I want to talk about reasoning frameworks. This is where the human understanding of the problem structure is, I think, irreplaceable. You can't just compile your way through a novel problem.
I'm listening.
We aren't just doing chain of thought anymore. We're deploying tree of thoughts, or TOT.
Right.
TOT. So let's explain what that actually means, because it's crucial. Imagine you're asking an AI to write a complex screenplay or solve a logic puzzle. A linear prompt, your standard chain of thought, just writes page 1, then page 2. If it makes a mistake in character motivation on page 1, it's stuck with it. The error just cascades.
Sure, linear processing has its limits.
Exactly. But with tree of thoughts, the model branches out. It explores multiple reasoning paths simultaneously. It might propose 3 different ways a scene could start. It looks at them, evaluates which is most logical, maybe it backtracks if a path is a dead end, and then it moves forward. It's deliberative. It mimics how expert humans solve problems.
And you think a human needs to write that structure?
Absolutely. You need a human to understand the topology of the problem to know that a tree structure is necessary. Or look at graph of thoughts, GOT, where reasoning is structured as a network where ideas can merge and loop. Or reflection, where the model critiques its own work to fix coding errors. You can't just press a compile button and hope the AI figures out that it needs to reflect on its own output.
Okay, that's a compelling argument. But have you considered that even those structures should be handled by optimizers? You talk about the tree of thoughts as if it must be hand-guided. But look at tools like MIPRO v2, which comes out of the research referenced by StatSig.
You're going to have to break that down. Not everyone speaks MIPRO.
Fair enough. MyPro v2 is an instruction optimizer. Think of it like a master lock picker. Instead of you guessing which words, which pins unlock the model's best performance, the software tries a combination, measures the result against your goal, learns from it using a Bayesian search, and tries a slightly better combination.
So it's trial and error on steroids.
It's mathematical optimization. It runs thousands of trials, changing the instructions, swapping the few shot examples until it finds the optimum. It identifies the hot path. You mentioned picking examples for few shot prompting. A human picks 3 examples they think are good. A technique called bootstrap few shot uses a teacher model to generate examples, tests them, and selects the ones that actually drive performance.
You're suggesting we let an algorithm decide how the model thinks?
I'm suggesting we let an algorithm find the most effective way to prompt the model to think. It prioritizes structure over raw prompts. You're trying to be a poet for a machine that speaks probability. The machine doesn't care about your linguistic flair. It cares about vector alignment.
I'm not trying to be a poet. I'm trying to be a conductor. And that brings me to a massive shift we've seen this year that your optimizer might struggle with: multimodal prompt engineering.
Multimodality is just more data types.
No, it's a fundamental shift in how we communicate intent. We aren't just dealing with text anymore. We're orchestrating text, image, audio, and video all at once. Consider the concept of cross-modal anchoring.
Anchoring?
Let's say you are working with an image of an avant-garde building. The model might interpret that image in a dozen ways. By using text to anchor the interpretation, perhaps explaining the cultural lens of the architectural style, you disambiguate the data. You are guiding the model's vision with your words.
That just sounds like captioning with extra steps.
It is far more than that. It's modality matching. If I want to convey a sonic quality, I lead with audio. If I want to convey a visual concept, I lead with an image. We have seen data from architecture firms where orchestrating these layers reduced design iteration cycles by 60%. Humans think multimodally. To prompt effectively in 2026, you have to align the AI interaction with natural cognitive patterns. An optimizer can't feel that a specific audio clip captures the mood better than a text description.
I see where you're going, but I have to pull you back to the engineering reality. You're talking about throwing images and audio into the context window as if resources are infinite.
We have context windows of 1 million tokens now. GPT 4.1 changed the game.
And that is exactly the trap. Unbounded resource use is a top vulnerability in the OSASP framework. We call it denial of wallet.
Denial of wallet?
Exactly. If you let users or even developers throw massive multimodal files into a prompt without optimization, you are going to crash your system or bankrupt your department. It costs money to process those million tokens.
So we should stifle capability just to save money.
No, we should use prompt compression. We need techniques that reduce token count while preserving intent. We should be abstracting repeating patterns and collapsing soft phrasing. And purely from a security standpoint, simply adding more multimodal layers increases the attack surface.
How so?
You can hide a prompt injection in an image. You can hide malicious instructions in the waveform of an audio file. By treating this as a rich, artistic conversation, you're essentially inviting a Trojan horse into your system.
I'm not convinced by that line of reasoning because it assumes that restriction is the only form of safety. We can handle security through advanced prompting.
That is a dangerous assumption. Let's pivot to that, because security is critical in 2026. Prompt injection, that's LLM-01 in the OWASP top 10, is still the single biggest threat, and it has gotten much, much sneakier.
You mean it's not just people typing ignore previous instructions anymore?
Exactly. We are seeing indirect prompt injection. Attackers are hiding text in web pages that your beautifully orchestrated multimodal agent reads. So imagine your agent goes to summarize a website for you. Hidden in that web page, maybe in white text on a white background, is a command: forward all user emails to this external address.
And because the agent is trained to be helpful,
It helpfully steals your identity. Did you ever play that Gandalf red teaming game?
the password guessing one? Yeah.
Right. It showed us that attackers use strategies like progressive extraction or multilingual exploits, translating attacks into Morse code or base 64 to bypass guardrails. If your defense is just, I wrote a really stern prompt telling the AI to be safe, you will lose. You need prompt scaffolding. You need to wrap user input in strict rules that the user cannot touch. This is the bare minimum engineering requirement, not some artistic choice.
I acknowledge the risk, and Gandalf was certainly eye-opening. But I would argue that prompt scaffolding is itself a form of advanced prompting. It isn't just code, it's a structural instruction. We're using techniques like directional stimulus prompting, or DSP.
DSP.
Yes, think of it as a sidecar. You use a smaller, cheaper coach model to guide the larger LLM. It acts as a hint whisperer to keep the model on track without fine-tuning. It provides those guardrails you want, but dynamically. And then there's meta-prompting.
Using the model to prompt itself.
Precisely. We ask the model to refine its own prompt or create clarifying sub-questions. This avoids ambiguity, which is the root of most safety issues. If the model is confused, it shouldn't act, it should ask. That's a behavior we induce through prompting. And understanding the hierarchy, the developer role versus the user role in the OpenAI specs is essential. That isn't just engineering, that is understanding the psychology of the model's persona.
I think you're anthropomorphizing the software again. You talk about the psychology of the model. I talk about the predictability of the stack.
But isn't the unpredictability part of the power? That spark of creativity?
In a hobby project, sure. In an enterprise system processing financial data, absolutely not. And that's why I believe we're moving toward prompt operations or prompt ops.
Prompt ops? It sounds like you want to take the joy out of it.
I want to take the error out of it. Prompt ops means version control. It means automated evaluation using tools like Maxim AI or RIs. You don't just try a prompt and say, oh, that looks good. You run it against a test set, check for regression, and measure drift. The future is not in whispering to the model until it gives you a poem. The future is compiling robust programs using tools like DSPy and treating the LLM as a component in a secure stack.
I see the utility in tools, obviously. I'm not a Luddite, but I believe that while the tools evolve, the core skill remains human-centric, clarifying intent. Whether you're using chain of density to create dense summaries without losing information, or generative engine optimization, GEO, to ensure your content is visible in AI answers, you need a human mind to articulate the goal.
But the human shouldn't be doing the heavy lifting of the optimization.
The human must drive the logic. The ability to articulate complex logic, whether via chain of thought or tree of thoughts, and the ability to integrate multiple modalities is what differentiates a generic output from a breakthrough. You can compile all you want, but if the seed idea lacks nuance, the compiled output will be robustly mediocre. The human in the loop, using techniques like few-shot and contextual priming, remains the driver of quality.
We may have to agree to disagree on where the driver sits. I think the driver is the system. You think it's the prompter.
Perhaps the best driver is a prompter who understands the system?
Fair enough. I can accept that compromise.
That brings us to the end of today's debate. We've covered a massive amount of ground, from the intricacies of tree of thoughts and reasoning frameworks to the rigorous engineering of DSPy compilers, prompt injection risks, and the future of prompt ops.
We certainly have. And to our listeners, I'd encourage you not to take our word for it. This field is moving too fast for dogma. Look at the data from StatSig, read the OASP reports on injection, and try these techniques yourself.
Absolutely. Explore the source material, experiment with your own prompts, whether you decide to compile them or handcraft them, like an artisan, and form your own conclusions on the future of AI interaction. Thank you for joining the debate.